It's an interesting and unseen trig question that we've got to deal with. We've got a circle, AB is the diameter, S lies on the circumference, D is the foot of the perpendicular, all this is on the diagram, and then OA and OB are both the radius, and OD is X. We're asked to apply the cosine rule to AOD to show that this is true. Okay, so I'm just going to highlight that triangle. So I know that that side is R. We're trying to work out this one, and then the bottom one is X. But I can do a little bit of work on that one because there's no X in the final answer. So if I just draw this triangle out, I've got theta, and actually this one here is R. This is a right angle. So cos theta is actually X over R, and X is R cos theta. So this is good. This is how we're going to get cos into the equation. That one there is R cos theta. I can also write down an angle. Okay, it's in terms of theta, but it's going to be 180 minus theta because we're on a straight line. And now I've got two sides and the angle that's opposite the one we want, so that's ready to use the cosine rule. I always use c squared is a squared plus b squared minus 2ab cos c because it has the strongest link to Pythagoras' theorem. If you want to swap the symbols around to get a squared is b squared plus c squared minus 2bc cos a, then fair enough. So I'm gonna label it, I think. This is going to become my capital C, and this is the little c that I want, and then I'll call this one A, and this side can be B. I'm not going to label any more angles. Therefore, it's going to be AD squared, my C squared, that's equal to R squared, plus R cos theta all squared, and then I'm minusing 2R cos theta multiplied by cos of 180 minus theta. Right, next line, that's going to become R squared plus R squared cos squared theta. Then I'm minusing 2R squared cos theta times cos 180 minus theta. You can actually see the result's going to work out if this becomes minus cos theta, but I want to convince you that it's true. I'm going to do that by drawing the graph of cos. So let's just pick a value. Let's say I had a value here. If I did 180 minus that value, it would end up here. It's kind of just flipped around, but due to the symmetry of the curve, it's just going to end up being the negative of what it was before. So hopefully that's enough. You can prove it using something called addition formulae in the second year. I'll be interested to see what other proofs people have, but before that little bit of knowledge. One other way we could do it is to use the fact that cos x, see this requires knowledge of this as well though, cos x is actually cos of minus x because it's actually an even function. It's symmetrical about here. If you do a reflection in the y-axis, it looks the same. So that's why that's true. And that means that cos 180 minus theta is equal to cos of theta minus 180. That might be a little bit easier to then visualize because if you have a value, say again here, actually it would end up jumping to here now. I mean, it's the same as the one before, but yeah, basically wherever you are, you just end up kind of in the same place but negative. In any case, this is something that you're going to need to figure out for this question, and we're very, very close now. So I'll get r squared plus r squared cos squared theta, and it will become plus 2r squared cos squared theta, which is r squared plus 3r squared cos squared theta. Finally, just factorize out that r squared, got the result required. Okay, quite a lot of effort and technical things needed for that question. Part B, we're told when BD bisects OS that this is true. Okay, when BD bisects, it's going to split these into equal amounts. Now, OS is actually the radius, which means that each of these is going to become R over 2. Pretty hard for me to fit this in, but that length there is also R over 2. And remember, actually, that's my value of X. So we had before, so X is now R over 2, but from before it's R cos theta. You can cancel out the R's. It must actually, it's no longer equal to X. I might just do this on another line actually. So cos theta is going to be a half. And we can put that in to our AD squared because I've got this other, remember, I've got this other piece of information. So AD squared is going to equal R squared K over 4 by squaring this thing here. And now I can set it equal to R squared 1 plus 3 times cos squared theta, but that's going to be a quarter. So I've just subbed in for cos squared theta. The R squareds are going to cancel. So I will be left, I'm just going to cancel them out here. I'll be left with K is equal to 4 times 1 plus 3 quarters. And I can either add them together and then times by 4. Actually, I can just expand the bracket. 4 plus 4 times 3 quarters is 3. K is going to equal 7. Right, bit of a different question. Not easy, I don't think, but I hope my explanation makes sense. Very well done on your effort.